Next topic is Spring Data, JPA. So Spring Data could be used with many different data storage technology, but in this presentation, we are going to focus on JPA. Okay. So let's talk about what is and why Spring Data first, and then we are going to focus on Spring Data JPA, and we will see the concept of Spring Data repository interfaces, and then we are going to build Spring Data JPA application step by step. I will talk about paging and sorting features of Spring Data JPA, and we are going to also see query generation strategies. So let's talk about what is and why Spring Data. So just the context of the Spring Data, understanding Spring Data. Data is the new frontier in computing. The amount of data is exploding, both in the enterprise and of course in the arena of social networking and personal data. So there is so much data being generated every single moment. And the types of data also exploding. So relational data that we are so much used to so far, like a table-driven and structured data, are not the only data type. And in fact, most of the data that are being generated these days are unstructured or semi-structured. Okay. And data management is a new strategic tool in business. So the data is actually becoming very, very important in many organizations. So the question that is being asked is even in Spring community, they need to have a bit new scheme. They need to have a new scheme to address these types of data, unstructured data, and also the amount of data that is being exploded right now. So that's the reason they actually come up with the Spring Data. So the types of data stores, you can actually see relational data is being used with the JDBC and JPA. And document store technologies such as the MongoDB and CouchDB, they actually save the data in the form of document. Those documents are typically in the form of JSON document. There are column-oriented database data storage technologies such as HBase, Cassandra, graph-based technologies such as Neo4j, OrientDB, and DataGrease, Gemfire, and Coherence, and key-value pair-based data store technologies such as Redis and the Riak, and big data is Hadoop. So each of these data storage technology has been developed during the past, let's say, 5 years to address this data explosion and being able to handle this unstructured data. So these guys have their, the strengths and weaknesses, and basically very specialized in some sense. So idea is that Spring wants to support all these different data stores. Not only on relational database, they want to be the number one to support all these different data storage technologies. So that's the reason Spring Data was born. So you can think of Spring Data as an umbrella project with an aim to provide a familiar and consistent Spring-based programming model for all these new stores. So we're not just talking about relational database, but we're talking about these all kinds of data storage technologies. So while retaining data store specific features and capabilities. So idea is that Spring wants to provide the consistent and portable APIs, yet they should be able to actually support all these different data store technologies. So they have sub projects on the Spring Data project. So Spring Data is an umbrella project, and underneath of Spring Data, it does have a Spring Data JPA, Spring Data MongoDB, Spring Data Neo4j, Spring Data Redis, Spring Data Solr, Hadoop, Gemfire, REST, and JDBC extensions, and there are a few more. Okay. Here we are going to mostly focus on Spring Data JPA. Okay. Spring Data JPA. So the features. So sophisticated support to build repositories based on Spring and JPA. So and support for query DSL predicates and thus type-safe JPA queries. So you can actually build a query based on Java objects so that they are type-safe. transparent auditing of domain class, pagination support, dynamic query execution, ability to integrate custom data access code, and validation of query annotated queries at bootstrap time, support XML-based query entity mapping, and Java config-based repository configuration by introducing enable JPA repository. So we're going to actually explore some of these features in this presentation and hands-on lab. Okay. So classes you need in plain Spring JPA. So if you are not using Spring Data JPA, so this is what we have used in our previous presentation. So Spring JPA, without using Spring Data JPA, you need domain classes. And you create repository, interface, and implementation. Okay, so remember we have student repository interface, and then you have JPA student repository implementation class. So we have to provide the implementation class using entity manager object, right? And then you are going to create a service class which is using repository class. Okay, so that the service class is the user of this repository class. So that was typical the structure of plain Spring JPA application. So if you actually go back to in fact our the Spring data here, and if you take a look at the database JPA Hibernate engine, so here key point is that we have to provide this interface, and then we have to provide this implementation ourselves. So using this entity manager, okay, right? And then we have, so in this example, we don't have any service service class. Instead, we are just using it directly in the main application, right? So we are just using student repository in the main class directly. But typically, in a reasonably good size application, there are in fact the services package. On the services package, you will have a service implementation that will use this repository. Okay, so that is a typical non-Spring Data JPA application. Okay, now let's take a look at the so let's talk about the pain points of plain JPA, Spring JPA application. So you are writing too much boilerplate coding, meaning you have to write same boilerplate code over and over. So if you take a look at this code, this JPA student repository class, okay. So the you basically have to use the entity manager over and over, right? Okay. So this is a bit simpler version of it, but basically the store is actually using persist method, and so every time you're actually writing some kind of the repository class, JPA repository class. So suppose if you have the JPA teacher repository class, then you have to actually write again similar code for that teacher repository class, JPA teacher repository class. And if you have another domain class, let's say school, then you have to have a JPA school repository class that actually provide again similar boilerplate code. So basically very similar code has to be provided for every single domain repository class. Right? So that's what we are talking about here. You have to write same boilerplate code over and over for all domain classes. And not type safe. JPQL is not really type safe. Okay, so it's because it's not really based on Java classes. And you have to deal with the pagination and sorting yourself. So in JPA itself does not really handle paging and sorting. You have to actually do paging. You have to actually provide paging and sorting support yourself. Okay. And code is not portable to other data storage. So once you actually write this kind of code, this is not really portable to other data storage technology. Meaning, basically you have to write the JPA version of the repository, JDBC version of the repository, MongoDB version of the repository, and the Redis version of the the repository implementation. So every single different data storage should have its own implementation of the repository implementation class. So that's basically what we are talking about. Okay, so these are the pain points of plain Spring JPA application. Okay, so now those pain points will be addressed by Spring Data JPA. okay? You still have to actually write a domain class. That didn't change, okay? However, this is a big thing. The only class that you have to write is basically just the interface. No more implementation. In fact, implementation classes are generated by Spring Data during runtime. This is the big feature of Spring Data. Okay, so if you are using Spring Data MongoDB, again, only thing you have to write is interface. The actual implementation class will be created during runtime for that MongoDB data storage. Okay, and service also can use the repository class. So the big difference is that you don't have to create an implementation class. Okay, and this interface is supposed to be common regardless of data storage technology. Okay, so if you actually go back to the pain points, you don't have to write any implementation code anymore. So no more boilerplate implementation code is needed. Okay, type safe. Yeah, we're gonna actually talk a little bit on this one later on. And the Spring Data comes with pagination and sorting support built in. Okay, so you don't have to deal with it. And code is not portable over other data storage. In Spring Data, your code is probably a lot more portable because you're just dealing with interface, right? And even this repository interface could be actually portable over different data storage technology because there is no implementation involved. In fact, implementation will be generated during runtime depending on what storage technology you decide to use. Does that make sense? Okay. So let's talk about the data storage interface. I mean Spring Data repository interfaces. Okay, so why Spring Data repository interfaces? So it's provided by Spring Data common projects, and then they are extended by data store specific subprojects. So you're gonna actually see JPA specific data repository interface. Okay, so there are common interfaces, and then we have data storage specific interfaces as well. It provides a consistent data access layer over various data stores. So basically, if you're using those common interfaces, then those interfaces should be able to be used over many different data storage technologies. So it enhances the portability of the code. Okay. Again, this is a big thing. No need to write data store specific implementation because implementation will be provided by the Spring container during runtime. Okay, all right. So these are common repository interfaces that are applicable over any data storage technology. So on the root, we have a repository interface. Okay, and the T is the type of managed entity, and ID is basically ID. Okay, entity's ID, and then CRUD repository is the subinterface of repository interface. It provides CRUD methods for manage the entity. So it does provide save, find one, find all, count, delete, delete all, and exist. So these are the set of methods that are defined in CRUD repository. So regardless of what storage technology you're using, these 7, these 7 methods are supposed to be supported in all overall data store technology, whether that is in fact a relational database or MongoDB, Couchbase, or it doesn't matter. Okay. And there is another interface called the paging and sorting repository. So this interface is for supporting pagination and sorting. Okay, so it does support find all, passing pageable object, and then you can also use a sort object as well. So we're going to see examples of this. So these are common repository interfaces over regardless of the data storage technology. Okay, any questions on this slide? Okay, now each data storage technology have its own set of specific interfaces. For JPA has a JPA repository interface. So it provides in addition to this functionality, the JPA repository interface will provide JPA specific methods, such as like a flushing the persistent context and delete record in a batch. Those kind of JPA specific methods are defined in JPA repository interface. And Mongo repository interface will have MongoDB specific methods. Okay, and there are the other repository interfaces, such as the NeoJ repository interface will have methods relevant only to NeoJ database storage technology. Okay, all right. So this is the repository interface hierarchy. So on the top you see repository interface is a root interface, and CRUD repository interface is a child interface of it, and then paging and sorting repository interface is a child interface of CRUD repository interface. Okay, and those are common interfaces that are applicable over any storage technology. And there is also what is called the query DSL predicate executor interface as well. Okay, and then on the bottom you have JPA specific interfaces. So JPA repository interface is in fact the child interface of paging and sorting repository interface. Okay, and there is also JPA specification executor interface. Okay, so we are going to mostly focus on the left side. Okay, so which interface do you want to use? So if you need JPA specific features in your application, and you are reasonably sure that your application will always use relational database, then you want to use JPA repository. Okay, otherwise you might want to stick with a common repository such as CRUD repository or paging and sorting repository if you need page and sorting. Okay, if you just need the CRUD based operation, then you can just use CRUD repository interface. Okay, so otherwise, meaning if you have a chance of possibility of moving to different data storage technology in the future, meaning instead of relational database you might want to use a MongoDB in the future, or if you need to support both, and that's not really unusual these days, you want to support both MongoDB and relational database, then you might want to stay with common interfaces. Okay, so that will actually provide enhanced portability of code. Does that make sense? Any questions so far? Okay. All right. So now let's try to build Spring Data JPA application step by step. Okay. So first of all, you are going to so as I said before, just this is the introduction of Spring Data JPA. So as I said, Spring Data JPA will create repository implementation automatically at runtime from repository interface. Okay, and basically all you have to do is to define query methods in the interface by just declaring it. So you define find by xxx, find by xxs and y, and find by and starting with find by not, find by something. So there are in fact a lot of find by things that you can define, right? And that's pretty much all you have to define. Once you define an interface of these methods, then the actual implementation classes implementing these methods will be created by Spring Framework. Meaning the implementation of these methods will be created by the Spring Framework. So your responsibility as a developer is just specifying, listing this set of methods in the interface, repository interface. Okay, so let's go through the steps. First, step number 1, you are going to create repository interface. Okay, and then you are going to add custom query methods. So, like these are custom query method. Okay, So and then inject repository interface into another component in the service object so that a service object can actually use it. Okay, so let me just repeat one more time. Step number one, you're going to create repository interface, and again, you can actually extend common interface, or you can extend JPA repository interface depending on the need. And step number two, you are going to add find by XXX query methods. Okay, and so this is an example: find by last name and first name method. Okay, and then you can actually use it, the repository interface, in another component like a service object. So service object will use implementation that is provided automatically by Spring Framework. Okay, so this is step one. So here we decided to create a custom repository interface. Okay, and we have decided to extend JPA repository because we are reasonably sure that we are going to stay with relational database. Okay, so by extending JPA repository, this customer repository inherits several methods for working with the customer persistence, including methods for saving, deleting, and finding, and customer entities. All these things are automatically available to customer repository interface. Okay. Okay, now we are going to add our custom query method. So here we want to provide find by last name. Okay, so find by last name and then argument string and last name, and it should return list of customers. So that's it. You don't have to actually write any implementation class of this implementation of this find by last name. That implementation will be created by Spring Framework during runtime. Okay, so this is to add custom query method. We just add one. You can add as many as you want. And then we can inject that repository object. So here, this is the customer service impl class, and it's getting customer repository object injected, and then it can actually use it right away in this service implementation class. Okay, so this customer repository is Java interface, right? So the actual implementation will be created and instantiated and injected right here. Okay, because we are using AutoWired here. Okay, so we're going to do exercise 1 and 2. So we are going to build simple Spring Data JPA application. In exercise 2, we are going to convert plain Spring JPA application to Spring Data JPA. It's a very simple process. Okay, so let's take a look at the lab documentation. So let's run this Spring Data JPA simple application first. Spring Data simple application. So let's just run this guy. Okay, so basically it does find, it performs find all, and it lists all the customers it found, and the customer found it find one. Okay, so that is the single customer, and the customer found it find by last name. So I actually tried to find any customer whose last name happened to be Bauer. So it found 2 people. Okay, all right. So if you take a look at the code, okay. So here we have a main method. Okay, so main application, and we are going to get the customer repository object. Okay, so customer repository object, and so you could certainly have AutoWired here if you want to, but we decide to actually call getBin method and call customer repository class, and then we are calling save method 5 times to save 5 customers. Right, and then we perform fetch, find all, and then we perform find one, then we perform find by last name. Okay. Now, key point in this case is customer repository.java file. So as you can see, that's all we need. We say customer repository interface extending JPA, and this is the type, and this is the ID. And the only thing we have defined here is a find by last name. Okay. And then we have a customer data, which is the just entity class, and we also have a data SQL. Okay, so in this case, if you take a look at the simple, we have data SQL. So we are actually adding 3 people, and also inside the code we are also adding the 8 people. Okay, so that's the reason we are actually seeing it is 5 people. So altogether we should have 8 people. So that's what you're actually seeing here. You see there are 8 people. Okay, 3 of them are added from data SQL, and the other 5 people are added in the code. Okay, right here. Okay, all right, and then domain class is just a customer, and the repository interface. Only thing we have is in fact customer repository interface extending JPA repository interface. Okay. All right, so for your own exercise, I want you to add find by first name method and to the repository interface, and add some code in the main application to verify the result. Okay, so this is actually find by last name. I want you to add a find by first name. Pretty straightforward. Exercise 2. Now we are going to convert Spring JPA application to use a Spring Data JPA. Okay, so let's run there is in fact starting code. So Spring Data JPA initial. So this is the code that does not use a Spring Data JPA yet. It's just using plain Spring JPA. Okay, so let's run this guy, and yeah, this is the one that we have worked on in Spring Data database application. So okay, so this is balance. Yeah, balance is $1,000, and total numbers transfer is 1. And then yeah, so this is the banking application that we worked in, the transaction data, Spring transaction hands-on lab. So initially it has $1,000 and $1,000 and $2,000, and then it perform one single transfer, and then we perform the second transfer. Okay, and we have a transaction error, so that's the reason we stay the same. So this one is transactional, this operation. Okay, so this is the one that we like to convert to use the Spring Data JPA. Okay, all right, so the step by step. So we have this repository. If you take a look at this repository package, we have account repository interface, and then we have the bank repository interface, and then we have a JPA version of both implementation, both interface. We have a JPA account repository and JPA bank repository. Okay, and again you can see we actually find by ID for the bank is basically using the same find method, and this is the same thing. It does use the find method. So same code is somewhat duplicated for each of this domain. Okay, all right, so what we want to do is we want to use the Spring Data JPA to eliminate this implementation class, so to speak. Okay, so we take a look at this, we take a look at that. And so what we are gonna do is, basically only thing we have to do is to make this repository class to extend JPA repository. Okay, and because because common repository interface supports update, you don't need this one anymore. Okay, the only thing that we need is the custom query method, the find by ID. Okay, so you don't need this one anymore. Okay, update, because that is being defined in the common repository interface. And the same thing for the bank. Okay, so we are going to have JPA repository. The entity type is bank. This is integer, and again you remove update. Okay, then you can actually remove JPA account repository Java and JPA bank repository Java. So you don't need these implementation classes anymore. Okay. and then you can modify account service import. Wait a minute. Yeah, so this is service implementation. So in the service implementation, we cannot, so we cannot use, in fact, the update. We have to use a save method because that's what is being supported in the repository interface. Okay, so instead of update, you are going to use a save method, and then when you make a change, it should work exactly the same. Okay, so I'm gonna give you guys about the 25 minutes to do this exercise. Next topic is paging and sorting. So if you need paging support, then you are going to extend paging and sorting repository interface. So the definition, if you take a look at the source code of paging and sorting repository, you can see it extends CRUD repository. It's a child interface of CRUD repository, as we have seen. Okay, so the two methods that it added to the paging and sorting repository is a find all, and you can add sort object as an argument, or you can paste the pageable object. Okay, and then it returns iterable t and or page t. So if you are asking for pageable the result, then it will return the page t. So we'll see example of how we can actually use it. Okay. So the then your interface, like a customer repository, will extend paging and sorting repository interface. Okay. All right. Now, page request is an implementation class of pageable interface. So you can pass the pageable type, and there are several implementation classes of pageable interface, and one of the implementation is page request. So page request object, you can set the page number, so which page you want to start, and the size, so basically the size for each page. And you can also specify the sorting direction, and then you can specify other properties. Okay, in fact, the page request, if you take a look at the page request, you could actually see there are multiple constructor methods of page request class. So let's see an example of page request. So first of all, we are performing two different page request and sorting operation, pagination and sorting operation. So here we are going to create page request object, and this is starting from 0, meaning it is actually page size 0. I'm sorry, paging number 0. Okay, and then we like to get the 3 as a size. So it will return 3 items in the first page. Well, actually, each page will be 3 items. So in our case, we have 7 customers, right? So 7 customers will actually return. The first 3 customers will be returned in this case. And then we can specify the direction of the sorting, direction.asc, so that is the sorting direction. And then you can specify ascending order of last name first, and then ascending order of email address among the ones that have the same last name. And then we are going to call find all. Then we pass the page request object we just created. Okay, so it will return page of a customer type. Okay, so in order to get the contents, meaning all the customers in that page, you call get content method of the page. So now customers is going to be list of customers. Okay. All right, so this is one example of paging and sorting. This is another example. So in this case, we are going to start the same page number, but the size of the page is just 2 items. So it will, in this case, return the first 2 customers. And now we can actually create the sort object. So here we create a sort object, and then basically we are going to create order object. So ascending order of the last name, and then the descending order of the first name. Okay, So we have a bit more control when we create our own sort object, providing new order object inside. Okay, and then we are going to pass that page request object to find all, and then again it will return page of customer type. Then we can get the content, meaning all the customers in that page. Okay, so that is exercise 3. So let's take a look at the exercise 3. So we are going to run Spring Data paging sorting application. So let's see, paging sorting application. So let's run this application. So in this case, this is find all without using any paging. So we have actually 6 customers: first name, last name, email, right? Okay, and then we have used page 1 request, and that's it's basically 3 customers in that page, and then this is the another page request. Okay, so let's take a look at the code. So if you take a look at the code, basically the only difference here is that we are now using paging and sorting repository. Okay, and then here, okay, so this is a find all. So this is not using any paging at all. So this is the case that we are actually creating a paging request, the first page and the 3 items. Okay, so this is an index in a sense. So this is in fact the second page and the 3 items. So that's the reason we are actually seeing 4 and 5 and 6, because each page has 3 customers, right? And we are displaying the second page. Okay, and then this is the last name, and email address is the ordering. Okay, and this one is the creating a page request, and this is the first page, right? 0 is the first page, and each page should have just 2. So it should return customer 1 and 2. So if you see the result, you can see it just display the customer 1 and 2, right? Okay. All right, so that is the result, and here we are just using data SQL. So if you take a look at the resource, data SQL, here we are just created 6 customers. Okay. All right, and for your exercise, create another page request object with page index set to 0 and page size is 2, and sort it based on last name only. Okay, yeah, I should actually say this one 1, because we already have done 0 and 2, don't we? Yes, we already have done 0 and 2, right? So it's pretty, so I'm gonna change it to 1. Okay. All right, so I'm gonna give you guys about maybe 5 minutes to do this exercise. Well, I'll give you 10 minutes so that you have time to digest the code. So query generation strategy. So there are 3 different query generation strategies. In fact, there are 4, including custom query generation, but we are not going to actually talk about it. So here you can generate a query using method names, and that's what we have seen so far. And then you can generate query using query annotations, and you can also generate query from named queries. So let's talk about each of these in a bit more detail. So query generation from method name. So you can actually specify find by something, and that's the way you can generate query. Okay, so find by ID, find name by ID, and so in this case, here what it returns is the whole object. Here is going to return just a name. Find by name or description. So you specify name and description. So it will perform find operation based on either name or that description. Find distinct by name. So the result should be distinct. Find top by name. Find top 1 by name. So this one returns a single entry, and this one returns a single entry as 1. Find first by name, so same thing, and find first one by name, is these are all same thing. Find first three by name, find first three by name, so you want to actually find the first three the items, ordering by name ascending. Okay, and find by name containing, you want to actually get anything that contains this particular name. So by constructing method names like this, you can perform query operation. Okay, so that is by using method name. The second scheme is query annotation. So this is used when you want to provide the query statement yourself, and it does support both JPQL and native SQL. So this is the case that we are using JPQL. Okay, so this is a JPQL statement. By the way, JPQL stands for JPA query language. Okay, it has a bit more, object oriented. So in this case, product is the the name of the class, not actually name of the table. If you're using SQL, you can specify the actual SQL statement. Okay, like this. And so here, these are all native SQL. So in this case, product is a table name, not actually the name of the class. Okay. Okay, and the third scheme is the named query. So name query is that you actually define name query in your entity class. So in your entity class, you say name query. The name of the name query is product find by name query, and this is the query that you want to provide. Okay, so this is entity class where you're defining this named query. Okay, and then in repository interface, you are going to actually use that the name in this case find by name query. Okay, so you can actually use that guy. Okay, and then in the query operation, you just use it in the same way that you are using other query statement. Okay. Okay, so that is the exercise 4. So let's take a look at the exercise 4. Okay, so we're gonna just run the application. Yeah, by the way, it's actually running this the Spring Data Query the project, and as you found, the somehow this product repository Java, so this is the definition of those query. Yeah, so this is the named based query. Okay. And this is the using query annotation. Okay, and this one is the named query. Okay, so in this case, if you go to the entity class, so if you go to product entity class, we basically defined this named query called the find by name query. Okay, all right, so let's actually run this guy first. So the thing is, in this case, yeah, somehow this one has this red tag. I don't know why. It seems like it's trying to consider, the named query is like a name of the name of the field, like attribute and value, right? So because it doesn't find the named query, it just complain about it. Okay, but when you run the application, it runs fine. Okay, so when you run it, let's just run it. Yeah, so just proceed. So it works fine. Okay, so basically it runs all the query find name of this guy, find distinct name, find first three, but since we are just using product 2, there is only one. Okay, so all these things are working correctly. Okay, so the code is pretty much what I showed you. So this is the examples of query generation using method names, and these are the examples of query generation using query annotation, and this one is using named query. Okay, all right, and then rest of the code is basically in the main application. We are basically using those query statements. So this is performing method names, query operation by method names. This is query operation using the annotation query based query annotation, and then this is using named query. Okay, so and that is pretty much it. Okay, all right, so I'm gonna give you guys about the 10 minutes to try this exercise.